And finally we come to the last rule, which is the negative exponent rule. Now we've seen this before, but we'll talk about it here again to solidify the concept. The negative exponent rule says that if you have a base a raised to the negative power of x, that should be the same thing as 1 divided by a to the positive x. Take 4 to the negative 2, for example. By the negative exponent rule, we know that that should equal to 1 over 4 squared, which is 1 divided by 16, or 1/16. Another example here, 24 times 12 to the negative 1 is actually equal to 24 divided by 12, because 12 to the negative 1 is the same as 1 over 12. If you multiply those together, what you end up with is 24 divided by 12, which gives you 2. And a similar thing applies with this problem. Okay, so here we have 5 to the 0 divided by 5 to the 0. We know that anytime you divide something by itself, you're going to get an answer of 1. By the quotient rule, you could also say that 5 to the 0 divided by 5 to the 0 is the same as 5 to the 0 minus 0. 0 minus 0 is also 0. That gives us 5 to the 0, which we know is equal to 1. Then you have this problem, 3 to the negative squared divided by 3 to the negative squared. There are lots of ways we can do this. We can use the quotient rule or the power of fraction rule. Let's use the quotient rule. 3 to the negative squared divided by 3 to the negative squared by the quotient rule should equal 3 to the negative squared, or 3 to the negative 2, minus a negative 2, which is actually a positive 2. So we get 3 to the negative 2 plus 2, which we know is equal to 3 to the 0. Any term raised to the power of 0 is equal to 1. And then again below here, we've just expanded it out as another way to do it. So that's something you can always do to check your work on a test or quiz. Lastly, we have 3 to the 5th times 3 to the negative 2. We know that 3 to the 5th is equal to 243, and 3 to the negative 2 is the same as 1 divided by 9. If you multiply 243 by 1/9, what you get is 243 divided by 9, which we know is 27. Okay, so let's go ahead and take a break here. When we come back, we'll talk about scientific notation.